Okay, I appreciate some of you skating into class this morning and making it here. Obviously, we're going to be a smaller group this morning, but let's get started. Let's talk a little bit about the interim videos and final projects first. How are things going with the final project? Did your users find your system obviously intuitive? No problems, no questions, no looking at you, no confusions? Were you surprised? Did you think they would find it intuitive and they didn't?
Found that if there was like, if the device wouldn't register at first, then it was a bigger problem.
Okay, right. So you're used to all the eccentricities of the leap motion device now, but your users definitely aren't. You probably had an idea going into your user testing about the weaker, the less intuitive parts of your system. Did your expectations about the non-intuitive portions line up with what your users found to be non-intuitive? Probably not, right? Okay, so as mentioned last time in interim video 2, you were demonstrating some of that to us. The idea is not to show us that your system is perfectly intuitive, but that you are being able to capture, at least in this video, from your user's perspective, places where things are a little bit weaker or less intuitive. In interim video 3, you're going to be submitting a video that is very much like video 1. So you'll be showing us that you've implemented some more of the functionality into your system. So continuing the above example, if you're adding in math to your system, you might show that your system now switches from displaying single digits to equations as a function of how well the user is doing. If they get confused and they miss a few, then maybe it switches back to individual digits and so on. One of the things we're looking for in particular in interim video 3 is you should show us somewhere in the video that there are improvements you've made based on your sort of preliminary alpha testing. So if there was issues about the device not registering your user's hand, add something in state 0 to make it easier for the user to realize that the device is the problem and they have to remove their hand and bring it back, or whatever it is you need them to do, right? So we should be able to watch your interim video 2 and see that your user had a problem with this point in your system and you tried to address that in interim video 3. That's really what we're looking for in this week's deliverable. Sound good? Okay, as promised, those of you that are taking the course for graduate credit, you're going to be doing more user testing than those taking this for undergraduate credit. So I've added a paragraph below, which is to the written report. So the additional user testing that those doing this for graduate credit are going to do, you're going to report on that additional user testing in your written report and your oral presentation. You need to find at least 10 different people and do 15 minutes of interaction with each of those 10 people. So start to make your list now and try and get people to agree to do this either over the Thanksgiving break or after you get back to campus after the break. Okay, so how is this going to work? It's up to you to identify, recruit, and schedule times to meet with your 10 users. If you submit at the end, I couldn't get 10 people and we're only hearing about it at the end, not much we can do about that, right? There's going to be a lot of people in the library studying for exams. Give them the opportunity to take a 15-minute break and learn a little bit of sign language. So make sure you find and recruit and schedule your people as early as possible. You're going to do user testing the following way. You're going to have the terminal window, so not the drawing window, printing out some text that looks cryptic to the user. So I've given you an example of what this might look like here. You're going to be writing out to the terminal window every loop through the infinite, every iteration through the infinite loop. And that text might be cryptic to the user, but when it's captured in the video that you're showing at the end in your oral presentation, it makes sense to the TA and to the instructor and to your fellow students. What it's demonstrating is that you're capturing usage statistics about how intuitive your system is. So for example, in this case, we're showing how long, or we're showing that the code is automatically logging how long somebody stays in one state versus the other. So they're in state 0 for 0.1, 0.2, 0.3 seconds. And then the system switches into S1. The user is in state 1 for 0.2, 0.3, 0.3 seconds, 0.2, 0.3 seconds. We're going to use all of that usage data, or you're going to use that usage data, write it out to a file, and then visualize it somehow either in Microsoft Sheets, Google Sheets, or with Matplotlib, if you're familiar with Matplotlib, for drawing visualizations. So you're going to take this raw timing data that your system is capturing and show that data visually, and show either the user is getting more familiar with your system or they're not, right? So given those raw statistics, how might you visualize those raw statistics to show that this particular user was confused, this particular user wasn't? What raw data might your system be able to capture to make it easier for you to see that in the data when it's visualized? So in Interim Video 2, which you just submitted, you can sort of see it anecdotally, right? Your user is using the system, and in the audio we can hear them asking you, I don't know what to do next. We want to try and automate this process. So what usage statistics could you capture here that would show confusion?
The percentage of time in each of the different states, or the ratio between them.
Exactly, right? So if we're capturing timing data about how much they're in these states and how often they switch from state 1 to state 2 and back to state 1 and so on, we could use that as a proxy for confusion, right? If their hand is constantly wandering outside the field of view or is becoming non-centered, then that shows they don't understand that they're supposed to keep their hand in the device's field of view and centered, right? This is just one example. You can capture whatever raw data you want from the system in operation and visualize it and show us among your 10 users who was confused and who wasn't. What I would suggest is doing a little bit of user testing with the subset of these users, so maybe 3 or 4 family members over the Thanksgiving break. Make sure you're capturing that raw usage data. You can work on the visualizations when you come back from break, and then do a larger capture with the remaining 6 or 7 users after you're back on campus. Make sense? Any questions about that? Again, we're not looking for you to demonstrate to us that all 10 of your users understood the system perfectly well. What you're trying to demonstrate in this round of user testing is that you can see automatically across the 10 users who's having a problem and who isn't, and at what point in the system. If three or 4 or 5 or 6 of your users are confused and the other ones seem to find it relatively intuitive, among the subset of confused users, were they confused in the same way? Were they all spending an inordinate amount of time in state 1, where their hand was in view of the device but not centered? Was it confusing for them to understand that they were supposed to keep their hand centered? Or not? Among that subset of confused users, they got stuck at different points in the system. How much information can you pull out about your users from this raw statistics as you can? Sound good? Any questions? Yes?
Can we change our program during the testing? Like the first people tested at the version 1 and
Absolutely. Sorry. So you can iterate as many times as you want through your code, right? So maybe you test with 2 of your 10 users, make some change, test with another 2. You can alternate adding and changing functionality and interleave it with testing as much as you want. That's fine. Okay. Any other questions? Okay. So back to the lecture material. Again, we're working our way through our last theme now on looking inward. So trying to cast an illusion that the user is not just in the physical world. We're either replacing the physical world with a virtual environment and trying to supply as much of the sensor motor expectations as possible. The user pushes against the virtual world and observes how the virtual world pushes back. Does that match or frustrate their expectations? We'll finish that lecture today and move on to augmented reality, where the user is still seeing and sensing the physical world in real time, but we are trying to add some virtual elements on top of what they're seeing and sensing in real time. So not swapping out the physical world, but augmenting it with a virtual overlay. Okay. So back to virtual reality. We talked last time about sort of the engineering aspects of this, the nuts and bolts. How do we actually create technology to close this real-time feedback loop so that when the user moves their head, for example, while they're wearing virtual reality goggles, they're seeing in 3D and the world is moving as they would expect. Their field of view is moving in relation to their head motion. We looked at that and realized that it's a lot more complicated than it seems. There are a lot of sort of subtle cues in the sensor motor coordination involved in head movement or body movement that need to be supported by the technology. What are some of the subtle elements of that feedback loop we talked about last time? There's some obvious ones, like when I move my head to the left, my field of view should move to the right, and vice versa. What was somewhat less obvious from the VR technologies we looked at last time?
People's eyes are different, so you have to adjust that for when you're looking side to side, so you just move over it properly.
Exactly, right? So you're wrestling with hand size differences in this class, right? There's also interocular distance, right? The distance between the user's eyes. Why does that matter?
Because the overlay of screens was dictated by the pupil distance.
The overlay of screens, which again, it's hard to see in this picture here, but obviously you get stereoscopic vision because you have two eyes that are seeing slightly different angles of objects that are in front of you. And the amount of disparity, the amount of difference in angle view of those objects tells you something about how far those objects are away from you. But that is a function of how far apart your two eyes are. Okay, we looked at a lot of those. We looked at the treadmills and the concave surfaces. A lot of those things are hard to get right, not just in terms of head movement and vision, but also walking. Let's look at a very simple example of this. Has anyone tried Google Cardboard?
My son has one.
Was he convinced?
He liked it.
Okay, let's have a look. So the idea here is we're going to take an extremely simple device, a piece of cardboard, and fold it in such a way that we slot in our smartphone and run a particular app. How much of this feedback loop can we capture with very, very simple technology?
Hey guys, I'm Will from Tested. I'm Norm from Tested. Norm, virtual reality is a craze that's sweeping America today.
Even hobos can do it.
Even, wait, we're not supposed to call them hobos.
Wow.
Transient.
The cardboard dwellers.
Yeah, cardboard dwellers.
Because now VR is open up to cardboarders.
Assuming you have a $500 smartphone.
Yes,
Okay.
absolutely.
Okay.
This was given out at I.O., and we have one. Our friend Matt Braga acquired it. Thanks, Braga.
He's our favorite Canadian.
And it's Google Cardboard. You might have heard about this.
Yeah.
And it's so funny because Samsung was rumored to be doing a VR style phone compatible frame that would be a real product, and now Google is turning into a joke. This is a joke of I.O.
You think it's a joke?
Well, we don't know. We're about to build it and figure it out.
Yeah.
So join us as we assemble Google Cardboard and experience Google's vision for low-cost virtual reality.
I'm a little skeptical.
It's open, but we haven't assembled it yet.
Yeah.
So this is what they gave out to attendees at I.O. This package here.
Yeah.
There are actually instructions on their website, I believe it's, what is it? g.co/cardboard.
There's not really instructions. It just says, here's what you need, and then put it together. Oh wait, here your cardboard design file. Okay, I've got a zip file, I'm downloading it, I'm opening it.
If you look here, it says, don't get this wet, and there are magnets inside. I'm not sure what that one is.
Do you have glue?
I do not have glue. Do we need glue?
It says we need glue.
Oh boy. Well, let's open this up. This is what it's supposed to look like, this picture right here. So when it's assembled, the phone will fit in there and it will be some type of virtual reality display.
This is the template, if you want to make your own.
Right, so this should be easy to out of this.
So it's a,
In the washer, that's the washer, that's the magnet.
you don't have a pacemaker, do you?
I do not have a basic, thank goodness.
Wow.
And where else
Dodge
is it?
it out
This is
there.
back here. Okay. Oh, okay. Come together.
This looks a lot easier than I was looking. Okay.
Challenging to see.
They give you a rubber band.
I see it pulled over.
Aha. Exactly. Exactly. Like that.
Right.
Oh boy. And oh.
Okay.
All right.
Face goes in here. I think you have to tap something to keep you doing it over and over again.
There it goes. Okay.
I want to see some virtual
All right.
reality. No,
So
this
let's
is
show
what
you
your
right now.
glasses.
Better. So I'm telling you because what happens is there's Google Earth right here. There's YouTube.
Yeah.
And this is accelerometer or gyro base. So
Okay.
as I turn, I'm looking around.
We're seeing both eyes right now, so you can see the cardboard on.
So photosphere
How do you make it?
and
Can
street.
you tap with your eyeball?
That's a very good point. Tutorial, tour guide, exhibit, windy day.
Tour guide seems like a good place to
All right,
start.
so I'm gonna put this in.
Okay.
Made for Nexus 5. There it goes. And this is my virtual reality machine now.
Maybe you're supposed to put the strap on your back, over your head, the rubber band.
What's the magnet for?
You know, that's a washer.
All right, so I'm gonna put
Maybe
this
the magnet
on,
just hold the washer.
and I'm gonna describe what's going on. You guys ready for this?
Yeah.
Am I ready to embrace the Google virtual world?
This is gonna be the best video we've ever made.
Oh, it totally works. My glasses don't fit well. My glasses don't
It
fit.
said that there's a notch that you can cut out to
Oh my God.
accommodate your
My glasses are too
glasses.
Glasses.
Language on. Everything looks blurry now, I bet.
No, it's all right. It's first of all, it's stereoscopic, 3D.
Okay.
So the icons that were popping out are now actually popping out at me.
Okay.
Maybe the magnet is how I activate.
How would you activate the magnet?
How do I access this? It looks really good because the Nexus 5 is a 1080p screen. It's actually a really good demo. I mean, in terms of the stereoscopic.
What are you seeing? Panorama picture.
Well, I'm still at the menu. I need to access the menu. I need to somehow tap in. How do I tap in?
When you insert your phone into cardboard, it's supposed to just launch the app if it supports NFC, which is the Nexus 5 should.
Okay. Now, how do I actually?
So what does the magnet do? No idea? He's confused. He's trying to do something. He's trying to click on an app.
Holds the cardboard together.
Not quite.
Allows you to touch your phone without reaching behind your eye.
You have to tap the app to start it, and there's one piece of metal outside the cardboard. That's the affordance, right? It's the single button. Trying to keep it very
Or
simple.
release the ring to click. Tilt to get home.
You know, it says you can turn a pizza box into a cardboard.
So if I want to go home, I just go. It's pulled from my Nexus library.
Can you go into our office in the Google Street View?
Oh, that would be cool. So it's right now showing you a photo that's stored on the Nexus phone,
Okay.
and it's showing them in panorama. So it looks for the photospheres and panoramas.
Okay, so you get the basic idea. It's a little bit of stereoscopic vision. He's trying Google Earth here, Google Maps. How can it be 3D if you take Google Maps data and project it through the two virtual cameras, the two virtual views in the phone? What needs to happen to turn that into a 3D image from the point of view of the user?
Just like the game, we took two perspectives, two virtual cameras, and we have two images.
So you need two virtual cameras inside Google Street View here. Is that possible given the Google Street View data set?
I'm just thinking, is it so close to your face that it's causing your eyes to go across, and that's what's giving you that illusion?
Possibly. Obviously, the screen is very close to your eyes. So remember our discussion about vergence and accommodation last time, right? So Google Cardboard's pretty close to this situation.
I feel like you could have two images that are slightly off center because Google Maps is moving through.
Exactly right. You've got the Google car that drove down the street to capture the images for Google Street View. So in theory, assuming that the car is capturing images in Street View that are overlapping and capturing street side images, and those objects are captured at slightly different angles, in theory you should be able to do it, right? It's hard to say without trying it how realistic it is, but we know what kind of data we need to capture to convince the human visual system that we're not just looking at a flat screen, but we're looking at a three-dimensional scene, right? So it's possible. Okay, so obviously the gyroscope and the accelerometer, there you're turning your phone into goggles, so it's capturing your head movement because it's attached to your head. The screen is split in two, so we could create stereoscopic vision. What other apps here might be relatively easy to write for Google Cardboard? So Street View would work, possibly, given the data set.
Maybe 3D game is a better app.
Possibly, right? So if we're doing a purely virtual environment, we can place virtual cameras wherever we want in that environment. Okay, so just a good HCI example about trying to do a lot with a little, right? Even with a relatively simple setup like this, if we exploit the sensor motor relationships that are possible with an accelerometer, gyroscope, and two virtual images, it's possible. Okay, so I think that's enough about sort of the technology of virtual reality. Let's do a little bit of history. So we're obviously trying to create an illusion where the user disappears into a virtual world. This is an old idea dating all the way back to the 1970s and MUDs and multi-user dungeons and so on. The original MUDs were obviously all text-based, which is just a reminder that humans have been trying to create virtual reality for much longer than going further back than the 1970s. If you write a good book, create a good movie, create a good play, you can create the illusion that the user is inside this virtual space that you're creating, right? So at root, virtual reality is about storytelling. If you convince the user that there is some structure to what's going on and you're supporting their predictions, we can do so not just with fancy graphics and head-mounted displays and omnidirectional treadmills. We can do it with text alone, right? So it's not just a technological problem. We're thinking very carefully about the psychology of predicting, of creating the illusion that the user is inside a virtual space. Okay, so let's look at a few examples, and some of these are dated. They're a little bit dated, and they're dated on purpose to sort of see how far we've come. You probably all have noticed aspects of your UVM education that are not ideal and you wish they could be improved. If we could deploy virtual reality, how could we create a better educational experience, or at least supplement the physical experience of being in a classroom or a study session and so on. So now we're going to try and think about, assuming we do have virtual reality technology and we can create the illusion that the user is inside of a virtual environment or a virtual experience, how can we adapt that to do something or support education in a way that is difficult or impossible to do in reality? What are some ideas?
Things like the writing center or any health-related center.
Okay. Okay, right. So there's lots of study centers on campus, and I imagine at this time of year they're probably pretty busy. Be nice to be able to interact one-on-one with an avatar, someone inside a writing center. What else is frustrating or difficult to do on a physical campus that we could facilitate with virtual reality to improve the learning experience?
Imagine for you just getting your ideas across even through a projector on the blackboard. You're limited by either your ability to write and how much space you have to actually display to us.
Possibly. So from the instructor point of view, instead of making PowerPoint slides, I could try and create virtual reality modules. Aside from the eye candy quotient of that, would it actually be more useful for you? if you were the instructor, the TA for this course or another course, what kind of virtual reality module might you create to support learning better than the traditional classroom and homework rigmarole?
If you could have like it would literally be in your face, good and bad examples of HCI interfaces.
Okay.
Especially in this unit specifically applied to virtual reality.
Exactly, right? It's a little bit meta, but all the best we can do here is watch someone use Google Cardboard. Could we create Google Cardboard inside a VR system where you could experience different VR systems inside a VR system? Maybe yes, maybe no. But hands-on first-person experience obviously is usually better than second-person or third-person perspective. You're watching somebody interact with an artifact, in this case, Google Cardboard. So we're doing things indirectly and trying to understand how this artifact works, how it might be improved. But you can't try it in the first person unless I brought in a whole bunch of cardboard and we all made Google Cardboard. But in virtual reality, maybe we could put you in a one-on-one interaction with the artifact or the object that we're learning about. Right? Okay, so let's have a look at another short video. This is from Ohio University, where they actually created a virtual campus to try and support education in VR. As you'll see from the video here, it's a little dated. How are they trying to support education and aspects of education that would be difficult or impossible to do on a physical campus? Obviously, it would be nice today if you could fly to campus.
Most of us have dreamt of flying. We've dreamt of a world with endless possibilities where reality falls away to be replaced by imagination, creativity, and endless opportunities for discovery. Discovery, so central to learning, has now broken free of the boundaries of the classroom. Learners now thrive in an environment unbridled by space, time, or even the laws of physics. Welcome to the Ohio University Second Life campus, an engaging new universe of learning opportunities for intellectual and professional growth. An immersive atmosphere where the classroom has not just been recreated, but rather reinvented. Learning experiences can range from entire college courses to one-hour learning modules. Learning comes in many forms. Learning kiosks are scalable systems for housing course content for blended or standalone delivery. Each kiosk houses applicable course content in a variety of possible media forms, from text to video, podcast, and more. The campus also contains substantial space for virtual trade shows and conferences. Second Life conference exhibits are a highly cost-effective method for ongoing contact with your customers. Art and music is alive in the Arts and Music Center, where artists, filmmakers, and musicians from Ohio University and all over the world display their talents. The Campus Student Center is where real-world student activities are enhanced by the rich collaboration made possible by Second Life. At the heart of Ohio University and Second Life is the same mission that drives Ohio University in real life: a complete dedication to the learning outcomes of our students and industry partners. Don't just dream of flying. Spread your wings and explore the Ohio University Second Life campus, where discovery is limited only by your own imagination.
Okay, we mentioned Google Glass at the beginning of the semester. A good idea in theory that kind of came and went. Same thing with Second Life. But again, at the time, there were a lot of HCI attempts to see how VR could be used to support different aspects like education. Don't all rush out at once to go to the Ohio University virtual campus. What seems to work there and what maybe doesn't work so well there?
I think that one aspect we haven't really talked about is it's really bad for your eyes to use, so they don't really recommend it for like more than 30 minutes, which is kind of why I think that just the shooty aesthetic.
Right, so maybe you don't want to wear goggles all day while you're on your virtual campus. My favorite segment in this video when you have the two people that are typing at each other.
If you could do all of that, why would you attend? Like, wouldn't that be a distraction from class?
That was the fear when Second Life first started to appear and people were building virtual campuses. Why wouldn't people just abandon traditional education and do all education in the virtual world? The virtual world may still win in the end, but at least for now, you're still here.
Oh, I didn't mean that.
Oh.
I just meant once you're in school and you realize you can fly and
Why would you stay there?
why would you do what you're supposed to do?
Because you presumably want to learn something on this virtual campus that would be easier to learn on the virtual campus than it would on the physical campus. But I'm not really convinced that that's the case. They tried to demonstrate a few attempts to do so in this video.
I noticed that the learning material is almost 2D, so I think that's no sense because we enter the virtual reality and we still stare at some screen.
Exactly, right? And again, everyone was trying to figure this out at the beginning. They have this virtual environment and they create a virtual web browser inside this virtual environment where you can virtually scroll through virtual web pages and watch virtual professors give virtual YouTube video lectures in the virtual browser page. It's hard to let go of very entrenched paradigms, right? The best way for you all to learn is to watch a professor stand up at the front of the class and talk or watch the video, right? Hard to break out of that paradigm. The hope with VR is that we can, but what? What would be a different way of delivering education rather than watching a virtual video lecture inside a virtual browser?
I mean, I guess if you're doing chemistry or something, you could actually use like real chemicals, for example, like watch the reactions go on without risking blowing something up.
Exactly, right? So first-hand experience is usually the best way to learn things, learn by doing. But in some cases it's difficult because we're dealing with dangerous chemicals or they're expensive chemicals and it's very difficult. So we're going to do things in groups of 2 or 10. It'd be great to do one-on-one, hands-on demonstrations, manual experience, right? Quote unquote manual experience. So possibly, right? Other ideas?
I guess I don't understand why you would need the virtual world in the first place.
Okay.
You watch a video or look at text, you just do that.
Why not watch a video of someone performing a chemistry experiment rather than trying to create the illusion, which is not easy to do, of the fact that you are doing it or attempting it or trying it yourself?
Because it's one thing to watch a video and it's another to actually like experience. And if you're someone living in a place where you could never afford to do that.
Okay, yep. So try learning a musical instrument where you don't have the musical instrument. You watch 2 or 3 hours of someone playing the instrument, and then you're handed an instrument and asked to replicate what you saw in the video. It's next to impossible, right? There are certain skills that you just seem to have to learn by doing it firsthand, but why? Some things you can possibly learn just by reading or watching a video, and others require firsthand manual experience. Why?
You gotta think it's about muscle memory, like a flight simulator. You wanna make sure you know whatever something happens that you're reaching the right direction.
There's something about muscle memory, right? There's certain aspects of operating a vehicle or learning a musical instrument or learning to sign language. What does this term muscle memory really stand for? So let's unpack that term from an HCI perspective. When you're learning something firsthand with an instructor and you're gaining this muscle memory, what is it that you're actually gaining?
So the brain and the hand, the body cooperate to create the experience of a feedback loop.
Exactly,
Yeah,
right?
So you know what's your movement and what's to expect.
Exactly. So when you're playing an instrument or learning to operate a vehicle, you are obviously engaged in a real-time sensor motor feedback loop. And it is very difficult to articulate explicitly. If you're playing a guitar and you feel the vibration of the strings through the neck, that gives you a subtle cue about how to move your hands at the next instant. But it's very difficult to articulate that. It's better to just do and build up that experience through muscle memory, right? So again, VR is definitely not there yet, but potentially you might be able to create enough of the reality of that feedback loop that you could teach something firsthand, even if the student doesn't have access to an actual guitar or vehicle or whatever the object is they're learning to interact with, because it's dangerous and expensive. And you're only going to allow them to move on to the physical experience when they've demonstrated increasing ability. That process, that pipeline from learning about it through text and video to firsthand experience in VR to eventual real physical experience, what is that pipeline? We've heard that in a different form several times throughout this course now. It's a different form of scaffolding, right? Could we expose the learner to virtual instances of this feedback loop before exposing them to the real thing? So there are some attempts to do this in other domains. So this is actually gaining a lot of traction in clinical domains, training people to be able to see a particular physical handicap or a mental challenge from the first person perspective, from the perspective of the person that is dealing with that particular challenge. You can go read about this particular project, which is an attempt to create a virtual model of the experiences of someone who suffers from schizophrenia, what the hallucinations are like, the admittedly scary repercussions of that. If you can actually place clinical trainees in that perspective, to actually feel what it feels like to suffer from that particular pathology, they might be a better clinician. We could also use it for outreach to educate the public about the realities of a given pathology, train practitioners, and ultimately treat patients. If you can take patients and put them in this virtual experience, we might be able to expose them to symptoms of the pathology, which causes them to react. But at least they have control over, in this case, the hallucinations or whatever it is that they're suffering from. We could place a joystick or a controller in front of them where they can then have control over the hallucination and turn it down or gradually turn it off. And by gradually giving the ability to control virtual hallucinations for some patients who suffer from schizophrenia, that gives them the feeling that they can control actual hallucinations when they occur. So that increased control over the symptoms of their own pathology and allows them to, in some cases, gradually desensitize themselves to the symptoms. If we can't treat the symptoms themselves with medication and therapy, can we at least try and train the sufferer or the patient to seem to have some control over it? Sometimes the feeling of having control over it is enough to deal with the pathology. Okay, kind of an interesting an application of virtual reality. Let's look at the legal implications of virtual reality. There are a lot of legal scholars who find this one very interesting. Again, this is a bit of a dated article here. This was sort of at the height of Second Life, which was the first sort of large-scale virtual reality system. It's an interesting paper from a legal perspective. The first question they asked is do virtual objects or virtual properties count as property in the legal sense? And at least for these legal scholars, the answer was yes, because the legal definition of a property is something that has value up front. If you pay for something, if money changes hands, that object has, and you exchange ownership on that object has value. If you then at a later date sell that object for the same amount or a slightly less amount of money, that exchange of money indicates that that object has held on to its value during the length of the ownership. So it's a product rather than a service. A service, once you pay for it and it's done, there's no more value, there's no more money changing hands. There are a lot of virtual objects out there that are now have great value. The second question is a little bit more controversial. If you have an avatar inside a virtual environment, Does that avatar borrow any of the human rights that the human operator of the avatar has? If someone commits a violent act on your avatar, can you sue them? See a lot of people shaking heads. Why not?
I think now the second life do not support the individual attack. I think.
So you can, if you're the company that creates the VR, you can proactively try and disbar any violence and just avoid the question altogether. Yeah. Other ideas? Yes.
Some people would never use VR if they do things that they don't really put in the world.
Okay, absolutely. So maybe it's up to them if they choose to enter into a particular VR system. So I complain to the company and I try and sue the company. Somebody performed a violent act on my avatar. The avatar is an extension of myself. Do I have a case? Yes.
Do some of the video games have ratings, so before you buy them, you know exactly what you're buying into.
Okay.
And negative ratings can have blood and violence.
Sometimes the point of the whole VR system is violence, right? It depends on the system. Do you think someone would have a case if they say the avatar is an extension of me and any violence upon that avatar feels like violence upon my own person? No? It's happening already. It's happening at an increasing rate, right? If the VR system is good enough and is able to create the illusion where you are seeing the virtual world through the eyes of your avatar, then at least from the user's point of view, they feel as if they are standing in the shoes of their avatar. From a rational point of view, of course they aren't. But if they feel as if they are in the shoes of their avatar, and someone performs a violent act on that avatar that they weren't expecting, yep. Exactly, right? So from a legal point of view, this is a no-brainer, right? We just put up whatever legalese we need to when you download and install and run the game. But that brings up a deeper issue, which is some people feel emotionally and physically attached to their avatar. Maybe from a legal point of view, that's no problem. It's possible, right? We could try as the VR corporation to put up some legal documents up front. But if you have a sufficiently sophisticated virtual environment, it's not so easy to be able to guess all the kinds of situations that may occur to the avatars, among the avatars in the virtual environment. Think about your own leap motion system that you're developing. You've probably already seen some interactions between your users and your system that are maybe unexpected to you because you're used to your system and you use it in a particular way. But especially for the graduate students that are going to be exposing their system to 10 users, you're going to probably see some unexpected interactions that you didn't think of beforehand. Yes?
Wouldn't it just be a virtual legal system? You would just have to get a virtual.
Good point.
There's also a lot of, exactly, so there are a lot of potential virtual lawyers out there, right? So that in itself is an interesting legal question, which is, do we need to create an entirely different legal system for virtual environments? What would be the pros and cons of possibly?
It's a virtual world. Does that then make the devs gods? So shouldn't it be up to them to dictate? Because when you enter the virtual world, I feel like there's a barrier between the virtual world and the real world.
Possibly, right? So we should suspend all expectations. We enter into a virtual environment. Who knows what's going to happen there? It's lawless, right? It just is what it is. Makes sense unless there's money involved, right? Now, if you have users that are investing economically in a virtual environment and possibly investing emotionally in what happens to their avatars in that virtual environment, it's not so easy anymore.
And adding laws and those break a lot of VR people, because a lot of people like going to VR to escape reality, their own life with nothing, really more.
Absolutely, right? So there's the escapist element to VR and computer games. It's something separate from the physical world. Even if I invest a lot of my own money in that world, the law does not apply, right? So either it's a lawless realm or we create a separate legal system for that virtual environment. These are actually important legal questions because, of course, there are a lot of VR systems out there in computer games that have huge economies in and of their own right.
Even if you pay money for it, you can still throw the legalese at someone, because at the end of the day, it's a product that's being exchanged hands, and the note of the barrier is important because you are choosing to subject yourself to this reality.
Yep.
And it's, even if it's super immersive, it's still separated from you. Now you think about it like if you make a very immersive movie,
Yep.
or something like that, then you have people suing movie studios for making a movie that's too immersive.
That's
They
it.
pay money for that.
Exactly, right? So there's this clear separation between the physical environment and the virtual environment. And that makes things easy from a legal point of view, right? The moment something enters into the virtual world, it's outside the legal framework of the country of the user. So I sell my beautiful beachfront property in Second Life for a huge amount of money, and then someone in another country buys it. So think about the actual currency. It's separate though, right? It's in the virtual environment. There's no legal implications to that action. Or sorry, I buy this beachfront property. So here in the US, I pay X US dollars for this virtual property. And then someone sells it in another country. It's bought, and then someone sells it and takes out of the virtual economy money in euros. What's the problem here?
So are you buying it with like physical money?
Physical money, absolutely. I am investing my own physical money in this object, and someone is buying it in another country.
Without paying taxes?
Is the virtual and the physical world separate, right? I mean, Bitcoin has maybe made this argument moot, but you get the idea, right? It's very difficult from a legal point of view to keep the physical and the virtual realms separate if there is physical money changing hands.
Don't a lot of kind of games and stuff have a centralized, so basically you'll pay, but it goes to the company for taxes on you, and then it gets redistributed out?
Absolutely, right? So that's ironclad. What could possibly go wrong with that, right? Whatever mechanism is put in place, someone will figure out a way to use the added complication of the virtual environment to abuse the system. Again, we're not going to try and solve this problem today, but just to recognize that there are interesting legal implications of these virtual environments. If someone is emotionally invested in what's going on in the game, they may wish to take the next step, which is to become economically invested in it. And the moment they do, the law or the laws of the countries involved come into play, right? If the virtual reality illusion is not very engaging, if I'm not convinced, then the game isn't very fun, or spending time in the VR is not worth my time. I'm not going to invest any of my own money in it, and it's not really a problem. As these games become much more engaging and there's much more money changing hands, then there are some interesting legal implications to this. We can decide that the virtual environment itself is lawless or has a separate legal system, but it's not sufficient if there's money going both ways. So let's talk about money for a moment. Again, this is somewhat dated. Second Life has kind of come and gone. But when it was first starting back in the early 2000s, there were some people that made some really interesting money in the system. So this particular user initially invested less than $10 in Second Life. And at the time I made this slide in April 2007, she had cleared $250,000. Not a bad return on investment. Second Life has its own currency exchange market. In April 2007, you could buy 300 in-game dollars for $1. On this particular day when I first made this slide, there were 5.4 million residents in the game or had signed up. 33,000 people were playing on that day. And between April 11 and April 12, 2.1 million US dollars had been spent in game, and people had made 325,000 from trading on the market alone, not buying property, but just exchanging money back and forth between US dollars and Linden dollars, so currency speculation. And that had grown in 2013 to 35 million users. And at that time, I wrote down the Gini index, which is a measure of economic inequality. So a Gini index of 0.9, as you can see here, is a ratio, which in this case tells you 10% of the residents owned 90% of the wealth, which is pretty unequal distribution of wealth. Not that different from some countries you may be familiar with. Second Life, again, has kind of come and gone, but even it's still going, and there is still a healthy economic market in-game associated with this virtual reality system. I'm sure we could do the same thing with World of Warcraft or whatever popular VR systems are today. Kind of interesting. Okay. So again, just continuing this, you can go read more about this on Wikipedia. In 2015 alone, they cashed out 60 million from the in-game economy. And in 2015, Second Life, which some of you may never have heard of, had a larger economy than some small countries. Again, I don't know about World of Warcraft today, but I would imagine it's pretty sizable. Pretty interesting, right? Okay. Let's go back to rehabilitation for a moment. We looked at some clinical applications. This is another one for war veterans who suffer from PTSD. Another example of trying to systematically desensitize people that suffer from PTSD. This is an interesting study to go read about. They put a lot of resources and time and effort into scaffolding the experience that triggers PTSD. So participants in this study would be placed inside an empty metal frame, which is eventually supposed to represent a Humvee or a vehicle in a theater of war. The subject sits in this metal frame of a vehicle and nothing happens. Gradually, the screen in front of them becomes a little bit more opaque and turns from a windshield into a screen through which they're looking at increasingly realistic scenes. And at any moment, if they register any anxiety, that is picked up by wearable technologies, and the reality of the virtual reality experience is tuned back down until they return to baseline, and then gradually the realism starts to creep up again. So it's an attempt to systematically desensitize PTSD sufferers to the symptoms that trigger an onset of anxiety. And it's done automatically through a real-time feedback loop between what they are seeing and what they are feeling and their own physiological response. Obviously, this is particularly difficult to get right. You can imagine the playing out of this feedback loop is very different for different subjects you place in this environment. The very fact that they know that when they relax, the realism of the experience is going to increase, that knowledge alone can be anxiety-inducing for some people that suffer from PTSD. Right? You can imagine some very challenging HCI issues in this technology. But it could be potentially very useful, again, if they get this technology right. Okay, so let's finish our discussion about virtual reality with something that's a little bit not as controversial. I want you to turn to your neighbor and spend a few minutes thinking about creating a virtual reality experience for a team building virtual retreat. So you have a corporation with employees distributed all over the globe. Most of them only see each other on Skype. Can we actually create an environment where, assuming we can get them not necessarily in the same place, but at least get them at the same time into a virtual reality environment? What kinds of experiences could you create to build trust among colleagues, get to know each other better, foster collaboration, allow junior members of the firm to start to develop leadership skills and appreciate one another's job? For most people, if you've ever worked in a company and you're forced to do one of these retreats, it's not the most fun thing to do. Can we try and make this a little bit more interesting for people to do and actually support in a better way in a virtual environment, building a better community within the firm? Okay, you can draw on some of the examples we've seen so far. You can dream up your own VR technology. It doesn't have to be technology that already exists. And again, the guiding theme here is, how would this be more acceptable to employees than having to do this in reality? This probably isn't something they're going to volunteer to want to do, so there's going to be a lot of resistance to this up front. We're trying to create something that is not just engaging, that draws the users in, but is also acceptable. It's something they're at least willing to try. Okay, take a few minutes to see what you can come up with, and then we'll discuss your ideas.
That's a good idea. And you wrote gamify. I was thinking, when you were talking about Second Life, you said, how come you create a whole environment and then just make it add another browser? I think that like making it like it's something that's enhanced by using computers, like what you would want to do. So like making it a game and something. So like
there is something really going on in the game, not just the reality.
Yeah. Yeah, and it can just be something simple, like if you hit the space bar, you're like, I don't know. Yeah, one guy, punch a guy. But yeah, I think that making it something where it's like, oh, this is a simple game. I mean, at actual retreats, you play different games that are like very intuitive and engrossing. Like, if you like, say like charades or something like that, or there are better examples like catchphrase or something, where it's like, oh, this game is fun.
Is there any thing we can foster the collaboration?
I think that there could be like a bunch of internet games where you have to like have people like build a bridge. I don't know, right?
Just like the team play, the team building game.
Yeah. Yeah.
Integrating that transfer between them so that they have you get
Yeah. Yeah.
Like creating a lot of virtual avatar for him to manage. Yeah, it's not really
Yeah. Or it could be like you can develop a game where somehow one person is an avatar but they can't do anything, and then you need another player to help that avatar in some way. So you could like be like flipping roles, where like the boss is now the one who needs to be helped, and then flip that and kind of have them play different roles. But the game would have to be like immediately intuitive. I think that's the choice.
Well, they spend too much time in the game instead of working because it's a company.
It's a whole big deal. They're a waste of time.
Just spend a lot of time with it in the game fight thing. Throwing.
How do you appreciate Ryan's job?
There would be a really clever way to do it. If you could develop like a
Yes.
a game where every member of the organization or team kind of like
Thank goodness they don't.
avatar version
Don't give them any ideas.
of actual job.
What's that? Especially in VR, exactly. Yes.
Yeah.
And then so you then if you did that, then the junior leaders could be the leaders.
Yeah.
So we did that in drawing and we were
Okay, so this may not be the most palatable thing for our employees at our hypothetical firm. Can we at least provide an experience that's useful and eye-opening for them? Ideas?
We were talking about a gamified version of dumbing down everyone's job in the company and then switching roles between it, so then your junior leadership could be in leadership, and then you would still have the chance to experience different things inside it.
Great idea, right? So let's dumb down everybody's job and make a simplified or metaphorical version of their job inside, inside virtual reality. One way to build up trust, obviously, is empathy. I work at the company. I'm convinced everybody else is inept, and I'm not going to attend any meetings, and I'm just going to do everything myself, right? Who knows the most at a company about everybody else and what they do? Most people obviously don't. Everyone has a partial view. If you want, you can think about UVM, your view of things on campus. Who knows more about what's going on than anyone else?
People in administrative and like assistant roles.
Exactly, right? So people in admin know the most, and it's usually the most junior members, the administrative assistants that know the most. For better or for worse, sometimes it's the senior admins that know the least, because they have the broadest view, and by necessity they have to sacrifice depth for breadth.
I think especially helpful if those junior administrative members were faculty before or students before, so they have that experience.
Okay, so obviously people change roles in an organization like a university or a company. Perhaps we could remind them of what things were like when they were in more junior positions.
I think like team-based games could like foster collaboration between people who wouldn't normally work together, or if you have everyone in the game like not be identified, maybe someone would get treated differently than they would when you knew who they were.
Exactly. Remember our discussion about social network influence, right? Humans are social creatures, and we change how we behave based on our understanding of where the other person sits in the social hierarchy. If you anonymize the avatars, you remove that information, right? Is the avatar controlled by my boss or someone who works for me, right? Could be kind of interesting. Something that would be difficult or impossible to do in reality. It's an interesting idea. Yeah. You mentioned have people switch roles, right? So I want to not just build up an empathy for other people at the firm, but an understanding of what actually they do. Right? That takes a lot of time and effort, and might not be the most fun thing to do, and I may be convinced it's not worth my time. Let's gamify it somehow and at least make it a little bit fun and a little bit interesting, but gamify it in such a way that you can't win the game by just doing everything yourself, right? At a lot of physical retreats, the games they choose are those in which the team that collaborates the best is usually the one that's going to win. Right? So again, we could replicate inside the virtual retreat models of things that work in physical retreats, or we could try and go above and beyond what's possible in a physical retreat, having people switch roles, anonymize participants. Could be interesting. Okay. Other ideas before we move on? Okay, so let's switch now from talking about virtual reality to augmented reality. Augmented reality, or AR, has its own particular HCI challenges because we are now going to assume that our participants are interacting with the physical world and observing or feeling the repercussions of the physical world at the same time as they're receiving sensory repercussions from virtual objects that are overlaid on top of what they're seeing and sensing in the real world. Again, this is not a new idea. You can trace it back to at least the 1960s, when our poor participant here had to wear a very heavy harness on the head, which was, as you can probably guess, trying to measure the movement of the observer's head and infer indirectly what they were looking at, and then supply, through goggles, back in the 1960s, sensory repercussions of head movement. Not very comfortable at the time, definitely not real time, but that understanding of trying to close that feedback loop has been around for a long time. If we want to overlay virtual objects on the visual scene, as I'm looking at the physical environment, I'm also seeing virtual objects. I need to know exactly what the field of view is like from the user's point of view. This is a difficult thing to do. You can go read about it at this URL, and there's a bit of a tongue-in-cheek description of the challenges here. We want to have two cameras that are capturing what the user actually sees. And as we saw in our discussion about virtual reality, getting head movement is not enough, right? Even head movement is not enough to resolve what the user is seeing to within a centimeter, a millimeter, which might be important. The best thing you could do is gouge out the user's eyes and place the cameras exactly where their eyeballs are, and then you'll be able to capture exactly what they're seeing. Not a very acceptable solution for most VR participants. So there are some very clever ways to do this. One of them is to create a goggle where the users are not looking at screens that are facing them head on. They're slanted a little bit. So on the inner surface of the screen is being projected what the user sees. Cameras are placed 90 degrees inside the goggles, pointing inward at exactly the same screen. But from the camera's point of view, the screen is mirrored. So it's capturing, again, exactly what the user is seeing. If you take the camera and rotate it about this diagonal axis, the camera will land exactly where the user's eyeball is. And so you can actually, with some clever optics here, capture exactly what the user is seeing. Although it is difficult. Imagine our user here and they shift their eyes. They don't move their head, but they shift their eyes, or they saccade to the right. Do we know that? And can these cameras compensate for that fact? So obviously, if I saccade my eyes to the right, my visual scene is I'm going to focus on something over here. What has changed from my point of view? Forget the cameras for a moment. I'm attending to some object over here, and I saccade to look at some object over here. How is my field of view changed, aside from the fact that I'm now focusing on this object? We're going to need to compensate for this with the cameras. The cameras need to be able to see exactly what I'm seeing.
Well, this is the first thing that popped into my head. If the cameras, instead of just capturing exactly what you see, if they could be wider than actually what you're seeing at a certain time, but capture your whole possible, like
right, your field of view entire. Yep.
Then it could be like, then the cameras wouldn't have to jack your eyes. You would just look to the side, and then you would see the other part of the scene that's out of your initial field of view.
Exactly. So, sorry, I might not have mentioned this, but whatever the cameras are capturing, that's what's being projected onto the inner surface of the screen. So the user is not actually looking through the screen, is not actually seeing the physical world directly. They are being fed what the cameras see. And if we get this right, it should feel to the user like that they are looking at screens which are actually glass. They're actually windows, right? They're seeing through the screens out into the world, which they are not. But it's hard to get this right.
Do they just rotate the screen with this data?
Possibly. We need to detect, first of all, that the user saccaded their eyes at all. So possibly we have another camera or we have some other sensor that is watching the user's eyes to know that they saccade. Possibly from the camera's point of view, assuming we can do this, we engineer the screen so that it is partially transparent, so that the camera is receiving the view from the outside world and also seeing through the reflection the user's eyes. Maybe we could do that. So assuming we can even capture saccades, the movement of the eye, we're going to have to alter what aspect of the camera's field of view is being projected onto these screens. Maybe rotating them would be a good way to do this. So in the same way that I saccade my eyes, maybe by rotating the screen, that changes what the camera is going to capture. That's an interesting solution. Other ideas? Turns out that this, as again, you can imagine, this is surprisingly difficult to get right. You can sort of get within 90–95% of what the user sees. Tricky to get exactly right. Why do we want to get to that resolution? Well, often if we're going to add virtual objects onto what the user is seeing of the physical world, we're going to have to project that virtual object at some distance away from the observer, which means the virtual object may occlude physical objects that are farther away from the observer, or the virtual object is occluded by physical objects that are closer to the observer. Okay, so here's an example from Magic Leap. Again, it's a little dated. There's better solutions now, but okay, no occlusion in this example, but let's go back to our little friend here under the desk. So you can see, obviously, in this case, it's being occluded by the upper surface of the desk. And again, this is just sort of a demo, maybe not that interesting or useful. What sort of applications for augmented reality could it be useful and necessary to get within a centimeter or a millimeter of accuracy in terms of occlusion? Okay, onto someone who's moving through an urban environment. Why would I want to see an overlay about construction? Okay, maybe we're pitching this to investors and we need to get it funded in the first place.
Perhaps on a smaller scale, say you're building a fancy IKEA cabinet.
Okay.
You can have the cabinet there so you know exactly where, how pieces should go.
Absolutely, right? So if you've ever tried to build some IKEA furniture, it's very difficult to do it from the instructions. It'd be very nice to be able to sort of interact in real time with the object as it's being assembled by possibly showing the next step already finished and you are just filling that in until physical reality matches the virtual reality. In 2 minutes' time, you're going to start walking across campus. It's going to be a little bit more challenging this morning than other times. So especially if you're walking somewhere and you need to think carefully about where to put your foot and how much pressure to put on that foot, you want to get a projection of where there is ice to be very, very accurate. Again, this is still an emerging technology. Nobody's figured this out, but you can imagine a lot of use cases for AR where you need to get the optics just right to project with very high fidelity of virtual environment, virtual objects on top of physical objects. I think we'll stop there today. You're working on Interim Video 3. You have a quiz due tonight, and I will see you on Thursday. Thank you.